As the world's population grows, so does the demand for goods. And to get these products to their destinations faster and more efficiently than ever before, engineers have been put to the test, blending technology with innovation to create the next generation marine engine.
Marine engines impress me because they're capable of that wide range of performance. They're second only to rocket engines in terms of their ability.
For centuries, diesel engines have been the mainstream within the industry. But now, new emission standards are shifting development in a whole new direction.
But still, we need some solution. How can we operate these large ships and do it in a sustainable way?
In response, engineers are turning to dual fuel technologies to power their engines, pairing diesel with alternative fuels. Electrical power is also surging to the forefront.
It could not only be the first all-electric ferry, it could be the first all-solar powered electric ferry.
And wind power is quickly proving its viability within the commercial shipping industry. Propulsion innovators are venturing out on an unprecedented path toward the future, designing and testing engines for some of the most versatile, fuel-efficient, futuristic sea monsters. Finland. This misty seafaring country is known for its stunning landscapes, vast coastlines, and mystical forests. The Finns have always been dependent on water transport to survive. 10% of the country is covered by water, and the majority of Finland's imports and exports are carried by sea. So reliable and safe transportation routes are vital to maintaining economic stability and national well-being. But since the country is located on the northern fringes of Europe, transportation to and from trade markets is difficult, especially in the winter. Finland is one of the only countries in the world whose ports all freeze over in normal winters.
This is a region where you are used to thinking, if it's not available, if it can't be bought, why don't I make it myself?
Towards the end of the 19th century, Finland was looking for a way to secure their economic future, despite travel restrictions due to the winter season. In response, engineers developed a new purpose-built ship called an icebreaker. With a new fleet of winter navigable ships at the ready, engineers were given another task: develop more efficient engines.
The early engines were quite small. They were built for small fishing boats, perhaps like this one that we can see in the background.
By the early 20th century, combating winter sea ice became a technologically solvable challenge for innovators like Finnish engineer John Vikström. John emigrated to the United States to study engineering. He settled down in Chicago and worked for a company that tested combustion engines. Soon John began to focus on his trade. And after finding success running a company that built boat engines, John returned to Finland, bringing with him his idea to create a fishing boat engine that ran on a caloric, or hot air engine. Unlike a steam engine, the caloric was boilerless and produced more power than a traditional propulsion system. Later, John refined his design, which used a four-stroke engine that could be powered by gasoline or diesel fuel.
So a diesel engine is in some ways similar to a gasoline engine. You've got four strokes. In the first stroke, you've got the intake of the air into the piston chamber. And in the second stroke, you've got the high compression that increases the temperature to a very high point. And just before it hits the peak, the atomized diesel fuel is injected into the chamber. The fuel ignites, and that's your power stroke. The fourth stroke is the exhaust stroke.
German engineer Rudolf Diesel took things to the next level when he developed a combustion engine that could operate on cheap diesel oil and was powerful enough to propel large ships. By 1938, the diesel engine era officially began. Enter Wärtsilä, a small ironworks company that was looking to expand on that principle.
Wärtsilä then acquired a workshop here in the 1930s, and that's where our long heritage of engine building in Vaasa started.
The original Wärtsilä factory is located in Vaasa, an industrial hub on Finland's west coast. It grew to be the region's biggest manufacturing company and a leader in the diesel engine revolution.
In the 1970s, Wärtsilä developed an engine that was able to run on cheap, heavy fuel oil. This became a real market booster because in the 1970s, it had fuel prices really shot through the roof.
You get performance and endurance that they had not seen before, and that fundamentally changed the shipping industry.
20 years later, engine development took another dramatic turn. As the world started to face the effects of pollution, engineers shifted their focus to energy-efficient power sources, such as liquefied natural gas, or LNG. Diesel engines were no longer the industry standard. Now, engineers were building ships that could run on dual fuel sources.
Using hybrid technology, you are able to have large savings, 15-20% in terms of emissions and fuels, even larger for vessels operating with a very intermittent load. This is an excellent solution, especially for short-range shipping and smaller vessels. We must remember that marine transportation with shipping is still the most energy-efficient mode of transportation, but still we need some solution. How can we operate these large ships and bring with us enough energy?
Today, Wärtsilä engines power a wide range of marine vessels. Their diesel engines are being built larger and more powerful than ever before. General Manager Mikko Kiitinen oversees more than 500 factory employees.
We have a very strict time schedule for the engines. 7 stations, 1 day per station, so in a 7-day engine will be ready.
Here, part assembly runs just as efficiently as the engines themselves. Each week, 3,000 parts are assembled through automation. But the engineering process still requires good old-fashioned Finnish know-how.
As you can see, engine manufacturing starts with engine blocks. This is the body and the heart of the engine.
Ultrasonic testing ensures that every component is assembled properly. On this tight schedule, and with millions of dollars on the line, there's no room for error.
It is sending sound waves through the components and collecting the data for the defects, things like this. This is the crucial part of the engine power system. All the power that comes from the engine comes through this part. If it's broken, the engine will fall down. So we are end of assembly. This engine which is covered now, the customer is waiting for witnessing the first start of the engine.
The plant produces 500 engines a year. This is a Wärtsilä 50DF. It's one of the biggest dual-fuel engines in the world. It runs on 8 cylinders and can be switched from natural gas to diesel fuel while in operation. The engine runs on lean burn technology. Lean burn engines are designed to produce a lower level of harmful emissions and improve combustion control inside the engine cylinders. This vital feature is what keeps the Wärtsilä 50DF at the top of its class. But as the marine industry evolves, engineers are being asked to come up with new fuel-efficient engines. Meanwhile, in one port city in Sweden, a brand new tugboat is making history thanks to its super-powered hybrid technology. For more than 100 years, the diesel engine has reigned supreme in the marine industry. Today, its development is driven by the production of bigger ships and an increasing demand for goods. And while sea traffic keeps getting heavier, emission regulations are getting tougher. According to the International Maritime Organization, or IMO, total emissions from the world's shipping fleet need to be cut in half by 2050.
They're under incredible pressure. You're asking them to change technologies, change designs, and change the ways they operate. This is a critical turning point.
Now, the race to improve engines isn't just about being the biggest and fastest. It's about being the cleanest. One of the first clean vessels is located in Luleå, a port city on the coast of northern Sweden. Meet Vilja. Vilja is the world's mightiest hybrid-powered tug. It can run on both diesel fuel and electric power sources. Chief Engineer Connie Smedqvist has been working on board Vilja since the tug was in its earliest stages of design.
They wanted us to help them to get a vessel that is suited for our needs, for the crew members' needs. And I think we did quite well.
The small but mighty Vilja escorts cargo ships laden with iron ore and other bulk goods. It can pull more than 110 tons, even in the harshest winter conditions.
It's really important because this vessel will be stationed in Luleå during the winter, keeping the fairway open. So it will act as an icebreaker the whole winter season.
It's the most powerful ice-breaking escort tug of its kind. It can break through nearly 3.5 feet of ice at a speed of up to 3 knots. The Vilja is also equipped with firefighting capabilities. The system can release over 300,000 gallons of water an hour. The Vilja is 120 feet long, slightly bigger than your average tug. It's 42 feet across the beam and can travel faster than most tugboats at more than 14 knots.
Compare this engine room set up with a traditional tugboat, it's like night and day. You don't need to start up one huge big engine of 8,000 horsepower. Here we can choose to start one engine, only 3,600 horsepower, and take the rest of the backup from the battery.
The tug is powered by 2 Wärtsilä 26 hybrid power modules that connect to a Z-drive thruster.
Each one of these engines drives its own shaft line with a permanent electric motors in line with the shaft.
This versatile vessel can work entirely on electric power, in hybrid mode with one engine, or in diesel mode with both engines. When it's on duty in the harbor, the tug starts in electrical mode with a simple push of a button.
For us to be able to live in this electrical mode, that's the best feeling because we start up quiet, green energy, meeting up the vessel that we should assist. Do we need 2 main engines or maybe just one?
The magic of this system is it can give or take power from 12 stacks of rechargeable lithium batteries made to last for decades. Lithium batteries are high energy. They hold more than 4 times as much power as a traditional lead-acid battery. So even though it's electrically powered, tug captains can be reassured that Vilja will never be dead in the water. Vilja's innovative propulsion system drives 2 propellers, each weighing over 80 tons, and it can recharge any time it returns to port.
One thing that we are really proud of is regarding the charging of the battery as well, because in Luleå we use a hydroelectric to charge these Corvus batteries, and to be able to use this stored power later on when we need, and it's green power. It's a really nice, efficient feature.
Batteries are a good place to put inland, inshore waters like where tugs would go. They're close to a charging station, and they're not going very far. So batteries have enormous potential as a fuel source for things like tugs.
As the world's first hybrid ice-breaking tug toughs it out in Northern Europe, Its batteries are expected to last up to 20 years. The hope is batteries will soon be able to hold a charge for even longer. Meanwhile, in Stockholm, Sweden, one company is utilizing a Wärtsilä engine to power one of the city's largest, most luxurious passenger ferries. This ferry is vital as it transports passengers back and forth between ports in Finland and in Sweden. But what makes this ferry truly unique is the fuel that powers it.
It's clean, emission-free. You get performance and endurance. Diesel's no longer king of the waters.
Stockholm, Sweden is one of the most dynamic cities in the world. But what makes it stand out is all the water that surrounds it. The city sits on 14 islands, making water transport a necessary part of life. Enter the Viking Grace, the largest passenger ferry in the city. The Grace is 715 feet long. That length is almost equivalent to the height of the Golden Gate Bridge. It's 104 feet wide. Every day, this massive vessel transports up to 2,800 passengers between ports in Finland and Sweden at speeds of up to 25 knots. The Grace is part commuter ferry, part luxury cruise ship. On board, passengers can shop in the ship's duty-free store, dine in one of the many restaurants, or simply relax in comfort. Another unique feature, the Grace runs on high-performance fuel. A traditional diesel engine produces as much pollution as thousands of cars, which could have a detrimental effect on the wildlife that call these waters home. Marine engineers in Finland designed the Grace to run on a combination of diesel and cleaner fuels. It's the first large-scale passenger ferry to run on liquefied natural gas, or LNG. But these new hybrid vessels come with their own set of challenges. LNG vapor is flammable, and it takes up a lot more space than diesel oil. On the Viking Grace, the LNG is stored in 2 tanks the size of small houses. They're made of 2 stainless steel walls with a vacuum in between. The tanks sit on the outside of the ship, because if one were ever punctured, it could ignite a fire.
The rules said that they have to be under open sky, because we don't like that the LNG will be heated up because of the pressure buildup.
The tanks are regularly refilled at the dock in Stockholm in a process called ship-to-ship bunkering. It takes less than an hour, but the fuel must be handled carefully. When it's liquid, the LNG is so cold, even if a splash of it were to get on your skin, it would cause severe damage. Once the tank is filled, a regassing unit at the front of the Grace converts it from liquid back to gas using warm water produced in the engine room. The gas is used to drive the ship's massive turbine. Engine temperature is just one of the many things Chief Engineer Jorn Lindström monitors below deck.
Well, here we can follow all pressure and temperature, so we can see the condition over the engines.
In the engine room next door, 4 Wärtsilä 50DF engines roar.
And they are 8-cylinder inline type, and each engine is developing 7.6 megawatt power and is connected to a generator producing electricity for the ship, like propulsion and ventilation and so on.
These engines use less fuel and give off lower levels of nitrogen and carbon dioxide than traditional diesel engines. The Grace is the ultimate green machine. It also uses excess heat from the engines to light the cabin decks. LNG may be the main source of fuel on this ship, but if needed, the Grace can switch back to diesel. Up at the helm, Captain Magnus Turnroos monitors the Grace's propulsion systems.
When we need extra power boost, we can choose from the bridge by dialing to the engine room. We can shift over by pressing a button here in the engine control room.
Switching over to diesel can come in handy when bad weather and high winds are detected out at sea.
This outside surface is so big and it causes a drift when we are in narrow passages. Last winter, for example, we had extreme winds. It's very unusual here.
Extreme weather can be hazardous on the open sea. Fortunately, the Grace is testing out a technology that takes advantage of this windy power source. It's called a rotor sail. It's almost 8 stories high, and in the right conditions, it can save 20% of the ship's energy needs.
When we have favorable side winds, it helps us to push us forward. We can reduce our engines from the bridge.
The rotor sail technology is based on the Magnus effect. When wind meets the spinning column, the airflow accelerates on one side of the rotor sail, then decelerates on the opposite side. The change in airflow results in a pressure difference, which creates a lift force that cuts down on power needed by the propellers. When wind conditions are favorable, rotor sails may reduce emissions on the open sea. But LNG is proving to be quite versatile. It's sulfur-free and meets all the new emission requirements. And it's helping to make oil spills a thing of the past. Before the Grace reaches its final destination, it makes a stop at the halfway point in Mariehamn in the Åland Islands to pick up more passengers. Captain Magnus operates the ship on his own from a side console. Once he approaches the pier, he'll have to navigate this $320 million ship in. It's a difficult maneuver.
The ship has to be in an exact position in order to get the gangways and all car ramps fitted. It's an exact science.
With passengers loaded, the Grace is back en route. But traveling into port won't be easy. Magnus has to navigate through a crowded, narrow waterway.
This is, of course, a challenge for us. We are so exposed to the wind, so the ship will drift a lot in the small, narrow passages.
It's dark by the time the Grace makes it safely to its final destination. This powerful vessel has safely ferried more than 5 million passengers since its maiden voyage. And it continues to make waves in the world of marine design. But what does the future hold for fuel-efficient solutions like liquefied natural gas? While the Grace has access to LNG fueling stations, some ports have limited resources.
The terminals that produce LNG are not necessarily close to the vessels that they need to refuel. So that's a pipeline problem. So with time, that can change. There's no rocket science in making that happen.
In Italy, Wärtsilä engineers are pushing the limits of technology yet again. Now, their goal is to develop an engine that could run entirely on zero-emission fuel. The Italian port of Trieste has all the beauty of Venice and the bustle of a major commercial port. The city is perched at the top of the Adriatic Sea, right next to Slovenia. It's home to the newest Wärtsilä hybrid engine testing facility.
This hybrid center covers multiple needs. On one side, it's a development center where we can test hybrid technologies from an operating and performance point of view. On the other side, we can use this full-scale facility, the first in the world of this kind, in order to validate every single component locally in the factory test environment before delivering to a customer.
1,000 engineers and scientists work at this center. every person here is engaged in a race to keep up with the new regulations in the shipping industry. And it's a race that's becoming a marathon. Shipping companies around the world need to keep more than their boats afloat. They have to keep their finances afloat too. The global marine industry will soon be worth $12 billion.
Sustainability is not only environmental sustainability, but it's also financial, economical. So the world economy is changing as well. And investors are looking to new technologies for the future, but not always able to invest on it by now.
In response, Wärtsilä is developing new ways of powering some of the world's hardest working vessels, bunkers, tankers, and fishing ships. The end goal? To achieve zero emissions.
What we see in this diagram is a typical marine propulsion system. Main components we have is an energy storage system. In our case, it's a battery-based energy storage system. And we have to add on the shaft line a piece of equipment, a motor generator, taking energy and power to and from the energy storage system.
Christer Vick heads the research and development testing team.
I'm checking that the emission levels are okay and the power output is as expected, that we are fulfilling the temperature limits of every component that we have and we cannot exceed any stresses and strains in the components, etc. So we are measuring a lot here.
Today, Christer and his team are testing the world champion of engines, the Wärtsilä 31. Only it'll be running entirely on highly flammable LNG. They watch from a separate room.
The engine that we were running today is a 10-cylinder Wärtsilä 31 engine, a dual-fuel engine able to run on any kinds of fuels, basically. This very specific engine is the one where we were proving the best efficiency in the world of a four-stroke engine.
The heat in the combustion chamber will be increased over a period of 10 hours. This will test the limits of how much heat this engine can handle. Now, engineers turn up the temperature inside the combustion chamber to 3,630 degrees. That's the kind of environment the engine will be operating in. The testing continues through the night. In the end, this engine proves to be a real workhorse, ready for the new marine frontier. Propelling ships across the ocean without emitting hazardous diesel fumes is the new industry imperative. Wärtsilä's engineers have met this standard head-on, designing ship engines that are reliable and efficient. But there's always room for growth.
It's a process that is never finished, never completed.
And engineers are under extreme pressure to keep up with the competition.
Development is getting faster and faster all the time, and competition as well. They are catching up, but this is why we put down a lot of efforts on research to be always on the forefront.
At the Hybrid Center in Italy, it's a high-stakes contest to come up with winning concepts for transportation on the high seas and to deliver them at full speed to a hungry market.
These types of engineers and scientists see opportunity in their challenges, and they're always itching for another challenge.
Policymakers have upped the ante in the competitive world of marine engineering. As companies like Wärtsilä strain to keep up with increasing commerce and tougher regulations, innovators all over the world are creating new types of engines. In the U.S., one community is testing out an engine prototype that could become the new industry standard in alternative technology. In today's fast-paced world, ferries can often get people to their destinations more quickly than any other mode of transportation. As marine industries struggle to satisfy strict emission standards, one rural town located along the Alabama River is home to the first all-electric passenger ferry.
When I was growing up, I remember riding an old ferry on the hill, like 2 cars on it. when I was about between the ages of 6 and 7 years old.
The community of Boyton, Alabama, also known as Gee's Bend, is located directly across the river from Camden, the county seat. Only one road leads in and out of Gee's Bend, and for years, a 2-car cable ferry was the fastest mode of transportation to cross the river. The trip only took 15 minutes.
The ferry service, for whatever reason, stopped in the 60s, right in the middle of some very tumultuous civil rights times, and certainly tumultuous times in Alabama in civil rights. And there was no ferry service for decades.
In Canada, they didn't want us to come to vote. It was only a few people here in vehicles. We didn't have no other way to get in there, but we finally made it.
And some very key local figures realized that was wrong.
Without access to the ferry, residents had to drive more than 40 miles to get to the nearest bridge crossing. Decades later, a diesel-powered ferry started operating on the river, but the vessel wasn't designed properly, so it failed Coast Guard inspection. 3 years later, the ferry got a complete overhaul and was transformed into a battery-operated vessel. But operating an electric-powered ferry requires electrical infrastructure, which isn't always readily available in a rural town.
We found that on the Gee's Bend side, there was only single-phase power coming to the landing. And to get the power down to the landing, we had to get the permission from landowners from 5 different parcels of land, and it took months to get those easements in place.
New infrastructure was installed on both sides of the river, and it had to be above flood levels. The ferry itself was renovated in the shipyard in Mobile, Alabama. New propulsion motors, propellers, and electrical converters were installed, as well as stacks of high-performance batteries. The ferry is 100 feet long. It has 4 propulsion motors powered by dual hybrid systems. It cruises the river between 5 and 8 knots and can carry up to a dozen vehicles.
All the cooling systems are new, the hydraulics for the steering system, and also for the ramps on the ferries.
And above deck, a new computerized console replaced the old navigation system. The refurbished ferry makes 5 trips up and down the river a day. Captain Ray Parker monitors the controls.
I just turned 70. I've been on the water all my life.
For the first time in his long career, Ray starts his day with a battery check.
If it's fully charged, I'm able to make my run, then I have to go from shore power to battery so the guys can unhook the shore power cable.
The ferry is also equipped with 2 independent sets of backup batteries and 2 rack rooms for power conversion.
This is where it converts AC to DC to go to our batteries, to charge our batteries, and then when we go to batteries, then it turns around and takes DC and makes it into AC for our electric motors.
This space below deck has been converted into an electric motor room.
We got our 2 electric motors, one for the bow, one for the stern, and then in the middle of them we got 2 hydraulic tanks and 2 hydraulic pumps. One's for steering and the other one's for ramps, picking our ramps up and down. It's a lot easier to clean, it stays clean.
When it returns to Camden, the ferry needs to be plugged back in to recharge. The process seems relatively simple, but running a ferry on electricity comes with its own set of risks. In this region, thunderstorms come with the territory. If a brutal storm were to hit, it could lead to a power surge.
We are in the southeastern United States, and we're very prone to convective thunderstorms. So the shore power team went ahead and put in some safeguards for us so that if any of the power systems on the shore get struck, that's not going to destroy all the systems on board the boat.
If the system ever did fail, a major reboot would be required.
You get on your computer and it won't do what you want to do or whatever, you just got to shut it all down and bring it all back up.
And if a battery mishap should happen out on the river, the ferry is equipped with an emergency shutdown system.
If we got say a battery fire or whatever, something happened, I could hit this and it would shut the battery supply off to it.
This ferry has served so reliably, it's now considered a prototype. Alabama's first all-electric ferry has proven to be cheaper and easier to run than the old diesel ferries. And there's very little maintenance required. The ferry's success is just one part of this now thriving community.
Gee's Bend is famous for its quilts and quilters, and this is another reason for people to come visit the community, so it certainly is helping with tourism.
A lot of tourists say they come on the field because they would want to get the experience of riding the field. Somebody asked me, since the ferry been back, all electricity, how does it feel riding the field? I said, well, it's the same ride. And that's the only thought, to me, it's quieter.
In 2003, more than 50 quilt makers founded the Gee's Bend Collective, an operation owned by the women of Gee's Bend. Every quilt is made by hand, intricately designed with bright colors and patterns. Some experts consider them to be among the masterpieces of modern American art. Thanks to the success of the ferry on the Alabama River, electrically powered vessels could be the solution to reducing carbon emissions and high fuel costs. But operating a massive container ship that moves cargo around the world on battery-driven engines requires a lot of power and access to charging stations, which aren't easy to find in the middle of the ocean. So what's next for high-performance, fuel-efficient engines? As the world's population increases, so has the demand for goods. And now, more than ever, efficient transportation is crucial to getting these products to their destinations. To meet this need, shipbuilders are designing bigger and faster ships. But powering a massive container vessel requires a mighty engine and tons of fuel. So the marine industry is under pressure to come up with an alternative to diesel fuel.
Diesel's no longer king of the waters. We have to find alternative methods that will also deliver the same power and performance.
Engineers worldwide are rising to the challenge. In Finland, one marine technology company has fitted their container ship with dual rotor sails, like the ones that have been installed on the luxury passenger ferry Viking Grace. Working alongside another fuel source, the rotor sails help reduce the amount of fuel emissions. Similar power solutions are also being implemented in other countries. In France, engineers are developing 2 pilot ships that combine diesel fuel with traditional sails. For now, the wind looks like a promising partner for diesel on the open sea. In addition to wind-powered technologies, solar-powered energy solutions are also being considered. Solar panels are already turning heads in the world of super yachts.
Some of these super yachts, they've come up with panels that are very efficient. They're able to now propel a large marine structure like a super yacht using electrical.
Big strides are also being made in the field of battery power. Commuter ferries around the world are going electric, like these new hybrid passenger ferries operating between Denmark and Sweden. They cut emissions by a whopping 65%. Europe also has car ferries that are following in the wake of the all-electric ferry in Alabama. This battery-operated vessel in Norway holds 10 times as many cars as the Alabama prototype. But it may be a while before batteries enter the big league of container ships.
That would be a lot of planning to stop a container ship in regular intervals to charge the batteries, but who knows? I hope someone will find it out and we will find good technologies there. But as we see it here in Wärtsilä, this engine still has a bright future for a long time, as long as we go for these special synthetic fuels.
The days of gasoline and diesel ships may be over. Now hydrogen-powered vessels are on the horizon.
Hydrogen has enormous potential. It's got 2.5 times the energy density of gasoline. It's clean, emission-free, but it's still very early days for hydrogen.
According to the International Maritime Organization, or IMO, total emissions from the world's shipping fleet need to be cut in half by 2050. So, time is of the essence. But thanks to today's innovators, there's no shortage of ideas being researched.
And there are some very promising ones, some of them in very advanced stages of implementation. So I'm quite hopeful.
I think it's a duty for each of us, whatever the profession might be, to contribute in a way in better sustainability on the planet.
For engineers around the world, there's a great deal of excitement as they take part in this planet-saving mission.
All of us that have been involved are proud, and the company is proud to show up this vessel and to see what we have accomplished.
It's very exciting because the technical development is so fast.
Someday we could be the first all-solar powered electric ferry, and who knows, perhaps further down the road it could be the first autonomous crewless vessel in the United States, perhaps the world.
Marine engineers and naval architects are building on a long legacy of innovation. From harnessing the planet's elemental powers, to building the mightiest engines, to designing systems that use new fuel sources and supersized batteries. The marine industry has proven it's not afraid to push technology and engineering further than ever before, as it continues to develop the latest, greatest sea monsters.